Daniela?
It's recording.
Cool. All right, so guys, when we get to 7.2 here, we're talking about graphing the results of a translation on a coordinate grid, right? So if you look at the example here, so why I showed you the stop motion animation or the flipbook animation is because this is what the cheesy example is giving you, right? He's taking this sailboat and he's getting it to go He's taking this sailboat and he's translating it over here. Now tell me, what's a translation as opposed to a reflection or a rotation? Translation is simply a slide, right? All it's doing is sliding across the screen. Now we're gonna put a bit of a wrinkle in this because it's gonna slide in 5 equal segments. You know how cartoons can sometimes look jumpy? Whereas you want it to be somewhat smooth and transition very easily. Obviously the smoother the translation is to have minimal movements in between each one, so you would have more slides. So I can make this move to here in 5 steps. I could also make it move there in 55 steps, and the 55 steps would obviously be a lot smoother, but we don't really care about that because the example they're giving us is with 5. So my original image translated to here. All I want to do is work through the 6 questions here. So our first question: make a copy of his original shape and final shape. Boom. Yeah? It's original shape and final shape. Now I screwed up, not that I screwed up, I don't like having numbers that end up in between lines, but that's okay, we'll work with it. So we go from here to here. Can someone tell me what we have to do for B?
Label the coordinates of the verticals of Hoshi's original shape and final.
Okay, so you guys are all looking on page 226. Somebody tell me here, I'll just go through these coordinates. What are they? F. I could figure them out in 2 seconds, but I don't feel like figuring them out. You tell me. What are the coordinates for F? Daniela?
-6, 6.
Beautiful. Someone, G. Better?
Yeah.
Okay, -9. Next, H. A. Come on, people, we gotta be quicker at this. Next, I'm gonna ask you B, so.
15 and 6.
B. C. D. And E. Now this is getting messy. I don't like it. We figured out the coordinates. I know you could all do the exact same thing for the translation. So basically what we're doing, if we go back to this is image 1, and we're taking image 1 and we're making it image 2. So we're obviously moving it that way. So how did we move it that way? So all you have to do is pick one coordinate. So we have to, for part C, it says write the translation vector for the translation needed to shift each vertex of the original shape to its final image. So pick a vertex. C? Okay, so C we said, was -12 and 8. And now what is the translated form of C? Okay, I see the 8. 8 and -2. Okay. So, what do I do? So, let's do some rough work here. Okay, so we want to figure out the translation vector. Okay, so you're basically we're looking at coordinates C, and I have -12, 8, and 8, -2. So I have 2 coordinates for X and 2 coordinates for Y. You need to figure out the difference between those 2 coordinates. Anytime you see the word difference, what operation are you doing? Subtraction, right? Would you start with the first number or would you start with the second number? I'm going to tell you, it really doesn't matter. You're just going to you'll end up with the same number, but you'll end up with the negative and positive. So if that will mess you up, I would say always start with the translated image. Start with the second image, right? So our basic work here, this is image number 1, and this is the translated image number 2. They're always going to denote it with a quotation mark or an apostrophe. So the translated image 1 will have an apostrophe, translated image 2 will have a quotation mark, translated image 3 will have 3 apostrophes, and so on. So we say 1 and 2. So we have 8. Now I'm looking for the difference. What do I do? 8, subtract. You got to participate here, people. Come on. Negative. Where are we with negative 2? Okay, and that will give me my x. And then how do I figure out my y? Negative 2, subtract 8. Shout some answers out, people. You guys are way too quiet. 20 and negative 10. Okay, so when I write my ordered pairs, I'm going to write them in circular brackets or circular parentheses. When you write your translation vector, you're going to have to put it in square brackets. And it's going to be 20 on the x and negative 10 on the y. Yeah? Okay, so now every single time you need to translate something, if you're working with the translation vector and trying to find out the translated image, all you have to do is take the original coordinates and add the translation vector. If you're trying to figure out the translation vector from the translated image, you take the second coordinates, just as we did right here, take the second coordinates, and you subtract or you find out the difference from the original coordinates. So honestly, all you have to do for this is addition and subtraction. You just have to remember which one you do it each time. If you have the translation vector, you add. If you're trying to figure out the translation vector, you subtract. Yeah? Okay, so now every single coordinate that I have here, all I would have to do is have my translation vector of 20, negative 10. So, someone, one last time, just so we get the idea here. Can you figure out f again? What coordinates is f? Now, if you're one of the silent people at the back of the room, please don't be one of the silent people at the back of the room that doesn't really understand this, because they don't feel like doing it twice. So, if we have negative 6 and 6, and I'm telling you that you know your translation vector is 20, negative 10. 20 on the x, negative 10 on the y. What is my translated f? So to figure that out, my translated f, I can simply go x coordinate for original image, x coordinate, and what do I do with my translation vector? So again, you got to memorize this little routine here, right? If you're trying to figure out the translation vector, you subtract. If you have the translation vector, all you got to do is add. So you have the translation vector, so you have the original coordinate for x, and you have the translation vector for x. So all you do is add them together. So what's that equal? 14. And so that's my x coordinate, and now we'll do my y coordinate. And so my y coordinate, original is 6, and I'm going to do what to it? I'm going to add negative 10, and that's going to equal what? 6 plus negative 10? I hear 4s, but I don't like the 4s. I hear -4. Let's check. So we go over to our translated image. We took the image up here and we translated it down here by that vector. Do we end up with the right answer? Of our coordinates would be 14, -4. Are we right? 14, -4. Easy stuff? Okay, now let's do D here. Write the translation vector for each of the 5 identical translations that can be put together to move the original shape to the final image. So basically what they're getting at with this is the original example was an animation, correct? If you had an animation from here to here, you obviously have to have some sort of shapes in the middle. Right? You're all with me? Because otherwise it's just going to jump from here to there and it's not going to look like a smooth transition or animation. So what they want you to do is have images, slowly but surely, get themselves there in 5 images, with this being the 5th image. So we got 4 images in between here. Now, can you guys figure out what our translation vector would be? We know our translation vector for number 1 to number 5 is 20 by 20 and then -10. 20 on the x and -10 on the y. Do you guys know how I would find what that would be in 5 incremental steps? It's honestly not as hard as you think. You have your total translation vector of 20 by -10. And how many steps do I have? 5. So what do I do, Arian? I divide by 5. So I take my original translation vector and I divide it by 5. So what does that equal? So this will be my step-by-step translation vector. And so my step-by-step translation vector is going to be 20 divided by 5 is 4, and -10 divided by 5 is -2. So for each of the 4 steps that it takes to get this image to this image, I'm going to have to move it 4 to the positive side of the x and 2 to the negative side of the y. So we try. Okay, really quick. F, and I'm going to move it by 4 and end up moving it down by 2. So if I add 4, if you want to work it out, you can work it out, that's fine too. -6 plus 4 and -2. Or sorry, 6 plus -2. And so -6 plus 4 is going to equal negative, altogether all at once here, come on, -6 plus 4 equals -2, and then 6 plus -2 equals 4. All right, guys, we're not really being all that loud here right now. And then I just simply put that into parentheses, which will be x and y, and I end up with -2, 4. -2, 4. Yes, no? So this is my F1. Now, it's going to ask you to do every single shape 4 times over. So every coordinate 4 times. But I don't need you to do every coordinate 4 times, if you get the basic idea of what you're going to do. Now I want to work through another example, probably not on this, but do we get the idea of what we did here? To go from F to F, I have to move it a total of 20 on the x and -10 on the y. If I break that up into 5 equal steps, I have to move it by 4 on the x and 2 on the y every single time. So what that is that F becomes the first translation of F would be down by 4, or to the right by 4 and down by 2. Yeah? All right, I'm done.